All right, so let me go ahead and do a video for you on 5-8, so you have a chance to watch this again as you're trying to do your homework and get ready for the questions that are on the final. All right, you've dealt with inverse trig functions back in chapter 3 when you were doing the derivatives of them. All right, in chapter 5, we're trying to integrate expressions that kind of look like what you see as answers to these. But the formulas differ a bit more than the other formulas. Like for most everything else we've done, if you knew how to do the derivatives, you could figure out how to do the integral. You really didn't have to do a lot of memorizing. But here I'm thinking you're going to need to just memorize these. So you need to know these. Okay. You don't deal with these kind as much, and they do vary more from the formulas back in chapter 3. Primarily because we don't just have to have a 1 in that first spot or in that spot. On those, we can have some number other than 1. That A can be a number other than 1. Okay. All right. So one of the things I want you to keep in mind is that when you're trying to compare the thing you're trying to integrate with these formulas to know which one to do, the A that you see is a constant or a number. Okay. So A is a constant or some number, where the U part is an algebraic expression. It might be like 2x, okay, or t to the second or something like that. Okay. And also the U and the A could be reversed. Okay. The second one in particular with arctan, the U and the A could be reversed. The U and the A really need to be in the locations they are for arcsine and arcsecant because of the subtraction. Okay. All right. Now, before we start doing the problem for real, why can't we do, I just want to touch on why can't we just do what we did in 5-5, okay? Where we would think about this as being 1 minus 4x squared raised to the negative 1/2 power, and then let u equal 1 minus 4x squared. Like what I'm getting at is how do we know that this might need to be one of these inverse trig function problems? Okay. Well, it's because when you do let u be 1 minus 4x squared and you do the derivative of that, you get a negative 8x dx, and there's no x with that dx. Okay. And that's a variable like that isn't something you can just throw into the problem easily. Okay. Now, the constant we could have handled, but it's that extra little x that causes the problem. Now, had there been an extra x on this, if this did have an x on it, then I would have been able to go further and just divide both sides by negative 8 and then start doing all the substitution stuff. But since it wasn't there, I can't do that. Okay. All right. So then when you feel like this probably is one of these inverse trig functions, you go and you look at the formulas and you compare, and you see that this one has a square root in the denominator, and that looks most like arcsine. So then you're thinking, this is arcsine. So what we're going to try to do is get it to look just like the arcsine formula, okay, by getting u's into the mix. So we're going to look at how the a squared would come from the 1. So a would be the square root of 1 or 1. And the u squared would come from the 4x squared. So u would equal the square root of the 4x squared, which would be 2x. Now, once you do that, you need to do kind of like what we did in 5-5 and do the derivative with respect to x, because we're going to replace all the x-related things with the u's. So the dx becomes 1/2 du. Okay. Okay, then we're able to come in here and think about how this is really, I'm trying to see it as a inverse. Let me pull that down again, as that top formula. So I want to think about this as being 1 squared minus 2x in parentheses squared. Okay. And then what I'm going to wind up doing is replacing the different pieces. Okay. So with things involving a u. So this is 1 squared minus u squared. And I want and then the dx I'm going to replace with, let me move it up a little bit, with 1/2 du. So let me just put a du here and have that 1/2 out in front. Okay. Now I've got that matching. I've got this right here now, this part, matching that formula precisely. And the formula says to do the arc sine of u over a, which is 1. Okay, so arc sine of u over a, which happens to be 1. Okay, and I've got a 1/2 out in front. I got to remember the plus c. And then the last thing I need to do is replace the arc sine with 2x. 2x over 1 would still just be 2x. And that will be my final answer. Right, so all of these are this type, where notice if I took the derivative of 1 plus 9x squared, I'd get an 18x. Look at number 2. If I took the derivative of the denominator, I'd get 18x. I don't have an x. So this isn't going to be one where I could use some technique like, you might have thought maybe this is a logarithm problem. But, this one you might have thought you could have done something like maybe the natural log of the 1 plus 9x squared and then adjust it. But see, the derivative of that inside would have been 18x, and you don't have an x. So can't do that. Now notice it has similarities to the second one. There's no radical. The 12 that you see on top is just a constant. I can completely move out of the way. The 1 is like the a squared. So a squared is 1. So a is the square root of that, or 1. And then the u squared comes from the 9x squared. And so that would wind up being 3x. I spoke while I was writing. 9x squared, which winds up being 3x. Okay, so I'm going to go ahead and do the derivative with respect to x there, like I did in 5.5. And I wind up having dx equaling 1/3 du. So now I'm going to get it to look just like that arctan problem. So the a squared, that's the 1 squared. The 9x squared is really 3x quantity squared. Okay, and then I still have a dx at this point. But I'm about to make a substitution. So here I'm going to have my 1 squared plus my u squared. Okay. And then in place of the dx down here, dx is equal to 1/3 du. And I'm going to go ahead and move that 1/3 out in front like I did the 12. Okay. So now this part matches the formula. And the formula for arctan says you're going to do 1 over your a, and your a value is 1, and then it'll be arctan of u over a plus c, and 12 times 1/3, that constant you need to bring down in front. So you're going to wind up with the answer being 4 arctan, and then in place of the u, put the 3x back in. Oh, and a was 1, so I don't really need to do that divided by. So that's arctan of 3x plus c. Okay? And then you're done. So if you know the formulas, these work pretty well. Okay? There are some little issues with the constants you got to work out, but that part works similarly to what we had in 5-5. So notice how number 3 does not have a radical. So that looks like an arctan problem. Number 4 doesn't have a radical. That looks like an arctan problem also. Okay. And so what I'll wind up doing is same thing we did before. Try to get this problem looking like one of the formulas and then apply it. Okay. So I'm going to figure out what my A is. A squared would be 4. So A will be 2. U squared equals x minus 3 squared. So U would be x minus 3. Okay. Now the derivative of U would equal 1 dx. Okay. So now I want to try to get this thing rewritten. So the 7 is a constant I can bring out in front. And then this is 2 squared plus x minus 3 squared dx. So 2 squared plus u squared. With the 7 out here, I haven't done a derivative yet. I'm still working on getting things in terms of u's. And then on this one, the du, hey, Bo, stop. The du and the dx were interchangeable because the derivative that we did back here turned out to be just 1 dx. So du can go in place of dx. All right, now it looks like the arctan formula. So the arctan formula tells you just go pull the formula, take a glance at it, see how it says to do 1 over your a, and your a is 2. Do arctan of the u over your a, which is 2, plus c, and don't forget about the 7 constant that you had. So that means your answer is going to be 7/2 arctan of x minus 3 over 2 plus c. Okay. All right, so let's try another one of those. So over here, the a, see on this one, these were interchanged, but that's no biggie because addition is commutative. And you might think because of the t that you have on top that you might have been able to do what you did in 5-5, but if you did the derivative of that denominator, wouldn't that be 4t to the third and you only have a t? So it's still an issue. So we're going to try arctan. So on that one, you'd have to recognize that a squared would have to be 16. So a is 4, and u squared would be t to the fourth, which means u would be t squared. We do square root. We show that. Okay, show that a little better. Okay, and then du would equal 2t dt. Okay. All right, now I'm going to do a little rewriting of this before I do the substituting. I want you to remember this is 1 over 4 squared plus t squared squared. And then I'm going to put the t along with the dt off to the side, just so you see it. So I'm trying to get u's into the mix. So it's 1 over 4 squared plus u squared. And then see the t dt? That means I need to get rid of that too. So t dt would be the same as 1/2 du. So let me get a 1/2 du in there. And let's go ahead and put that 1/2 out in front while we're working on that. So now we have it looking like the formula, and we're ready to do it. We need to do 1 over our a, and then it would be arctan u over the a plus c, and then you have the 1/2 already that you need to bring down, which makes it 1/8 arctan of t squared over 4 plus c. Okay. All right. I'm going to go ahead and stop and do a separate video for the others.